Okay, class. So in this video, we'll be discussing the second part of the applications ng higher order differential equations, which are electrical circuits. So in this figure class, we have an electromotive force. This is E, resistor R, inductor L, and capacitor C. So they are in series with each other. So we have discussed that the capacitor charges over time. So if we have, let's say, time t, and Q is the charge of capacitor, then the charge at any given point in time, that is Q of t. So the current class, this is the rate at which charge flows to the circuit. And this is described as I. So this is the rate siya, kung gano'ng karaming charge kada segundo with respect to time. So it's actually the derivative of Q with respect to time. So by definition, we know the voltages across the elements are as follows. So as defined, we have the voltage at R, that's IR, the voltage at the inductor, that is L di over dt. I think natakil natin to sa first order applications. Also, ito rin, VC is equal to Q over C, charge per coulomb. So, wherein yung VR natin, voltage at the resistor, VL, voltage at the inductor, VC, voltage at the capacitor. R natin is the resistance in ohms. L is the inductance in Henry. Q is the charge in coulomb. I is the current in amperes. And C is the capacitance in farad. So, yan yung mga parameters natin. So, if we apply Kirchhoff's voltage law, this means that the sum of these voltages daw ay equal to the voltage drop E. Or to be exact, in a loop, the voltage drop is equal to 0. So, kapag nilipat mo yung E sa kabilang side, then equal siya dun sa lahat ng voltage drop ng bawat component natin. So, taking that into consideration, nag-Kirchhoff's tayo, nag-loop tayo dun, we will arrive at this equation, VL plus VR plus VC is equal to your electromotive force. So, substituting natin yung mga value ng VL, VR, at VC, we'll arrive at L di over dt plus Ri plus Q over C is equal to E or E of t. So, in this case, class, ang E natin or ang voltage natin is a function of time. So, pwedeng sinusoidal siya or nagbabago-bago yung value niya with respect to time. Now, since ang I natin is dq over dt, so substitute natin sa equation, that is, ang I natin, palitan natin ng dq over dt. Now, alam natin that I is dq over dt. If you take the first derivative of I, that's di over dt, di ba? So, di over dt is actually the second derivative of q. So, itong di over dt, pwede natin palitan ng d squared q over dt squared because we know that that di over dt, that's the first derivative of I, and the first derivative of I is the second derivative of q, which is d squared q over dt squared. So the resulting equation, class, is a non-homogeneous because may E of t tayo dito, second order linear differential equation with constant coefficients. Now, this is a second order na differential equation. So, ibig sabihin, we will have two arbitrary constants. And if we will have two arbitrary constants, we need two initial conditions para malaman natin yung kanilang value. So, ano naman, class, yung initial conditions na gagamitin natin? So, alam natin that at the start of the system, di pa tayo nag-on ng switch. That is at t is equal to 0, wala pang charge yung capacitor natin. So, therefore, at q of t or at q of 0, ang value ng Q natin is equal to the initial charge natin. So, sasabihin naman yan kung may initial charge siya. Next, we have the Q prime, which is your first derivative, which is the current. So, at t is equal to 0, alam din natin na equal yung current mo to the initial current of the circuit. So, kung may initial current yan or nag-start ka at current is equal to 0, then that the second derivative mo at t is equal to 0, that's equal to the input current IO. So, ito yon, hindi pala input current, initial current. So, we have initial charge, Q sub O, and initial current, that's I sub O. Now, apply natin sa problem. Kasi, nakita naman natin, di ba, ang kinalabasan is a non-homogeneous differential equation. So, kung non-homogeneous differential equation yan, we can use the method na pinag-aralan natin last time on solving non-homogeneous differential equations. So, we have find the charge Tau at any given time for the circuit below if the initial charge and current are both 0. So, ang pinapanap sa atin is a function of charge with respect to time. So, ganun lang. Yun lang kailangan nating hanapin. A function relating charge and time. So, medyo mahaba na to. Siguro, kung ina-expect nyo na medyo mahaba to. So, using the values given, so the differential equation will be, we have q double prime plus 40q prime plus 625q is equal to 100 cosine 10t. So, take note, q double prime natin is, ang L natin is 1. Tapos, ang R natin is 40. Tapos, ang C natin or 1 over C natin is 1 over 16 times 10 to the negative 4. And 1 times 10 to the negative 16, 4 inverse or raised to negative 1 is 625. So, equal to 100 cosine 10t. So, this is our equation. So, kung napansin, kailangan nating kunin yung ano niyan. Kunin yung general solution yan or particular solution. So, obviously, medyo mahirap to. Now, we have two methods. So, we can either use the method of undetermined coefficients or the Laplace transform method. So, either is parehas. Now, I suggest, kapag solve natin to using the method of undetermined coefficients, pero kung natapos natin yung problem, try nyo isolve using the Laplace transform method and that parehas tayo na makuha ang answer. Okay, using method of undetermined coefficients, that is Q, or the general solution is equal to QC plus QP. QC is the complementary, Q is the particular. So, first, let's solve for QC. So, ang QC natin is just the general solution na to. That is Q prime plus 400Q, Q double prime plus 40Q prime plus 625Q. We get the auxiliary equation that is lambda squared plus 40 lambda plus 625 is equal to 0. So using quadratic formula, we can get the roots, and that is lambda is equal to negative 20 plus or minus 15i. So they are imaginary. So if they are imaginary, complex conjugate sila. So ang complementary function natin will be QC, this will be equal to e raised to negative 20t C1 cosine 15t plus C2 sine 15t. So this is based lang sa sa discussion natin on how to get the general solution of complex conjugates na mga roots. Now, solving for QP, so using method of undetermined coefficients. So ang Rx natin is equal to in this case that's R of t. So ang R of t natin is 100 cosine 10t. Again, kapag nagbe-method of undetermined coefficients tayo, what we do is find an appropriate form of our QP. So in this case, this is 100 cosine t. So if we will look at our table ng mga probable QP, ang ideal na QP for 100 cosine t or for kapag meron tayong cosine ay ito, A cosine 10t plus B sine 10t. So ito yung gagamitin natin na QP. And then we will now find for the value of A and B. So we will assume that this is the right form of your solution for 100 cosine 10t. Now, we solve for the coefficients. So, to solve for the coefficients, we need to find the derivatives. Kasi, ang gagamitin natin class, if QP is really a solution to 100 cosine 10t, then it must be able to satisfy yung QC. So, pwede natin siya dapat i-substitute sa QC. Now, we solve for the coefficients. First, find the first derivative. We will have Q prime of P, that is equal to negative 10A sine 10T plus 10B cosine 10T. Next, we find the second derivative, that's Q double prime P is equal to negative 100A cosine T, 10T minus 100B sine 10T. Yan. Now, we substitute to our equation. Ang equation natin is Q double prime plus 40Q prime plus 625Q is equal to 100 cosine 10T. Remember, if this QP is actually a solution to your to our differential equation, then dapat masatisfy niya na kapag sinubstitute natin siya dito. So, we substitute that to our equation. Ang Q prime natin is negative 100A cosine 10T minus 100B sine 10T plus 40 times ang Q prime is, Q double prime pala yung kanina. So, 40 times Q prime is negative 10A sine 10T plus 10B cosine 10T plus 625. Ang Q natin is A cosine 10T plus B sine 10T is equal to 100 cosine 10T. We simplify para makuha natin yung values ng A and B natin. So, multiply natin itong 40 na to sa negative 10A sine 10T plus 10B cosine 10T. We also multiply yung 625 sa A cosine 10T plus B sine 10T. So, we will arrive at this equation. Negative 100A cosine 10T minus 100B sine 10T minus 400A sine 10T plus 400B cosine 10T plus 625A cosine 10T plus 625B sine 10T is equal to 100 cosine 10T. We further simplify. Pag samasamahin natin lahat ng may cosine T, tapos i-factor out natin sila, ay yung cosine 10T. Tapos pag samasamahin natin lahat ng may sine 10T, factor out natin sila. So, ito may cosine 10T. Ito rin. Tapos ito. Tapos ito naman yung may sine 10T, tapos ito. So, factoring out, we will have cosine 10T times negative 100A plus 400B plus 625A plus sine 10T minus 100B minus 400B to plus, tama, A pala talaga siya. Joke lang. Negative 400A plus 625B is equal to 100 cosine 100T. So, simplify natin. Pag samasamahin na lang to, this is negative 100A minus 625A. Tapos, negative 100B plus 625B. Then, we take now the coefficients. We have first, the simplified version pala muna. We have 525A plus 400B cosine 10T plus negative 400A plus 525 sine 10T is equal to 100 cosine 10T. Let us first take the coefficients of cosine 10T. And that is 525A plus 400B is equal to 100. So, ito lang naman yung may cosine 10T. So, therefore, we will arrive at this equation of A and B na 21A plus 16B is equal to 4. Next, we take the coefficients of sine 10T. So, that is negative 400A plus 525B. So, we will arrive at negative 16A plus 21B is equal to 0. But we have two equations, so we can do elimination. So, we have yung 21A plus 16B natin equal to 4. I-minus natin sa 16, i-add natin siya pala sa 16A plus 21B pero i-multiply natin sa 21 by 16 para may mag-cancel. To be specific, ang mga-cancel dito is yung A. So, we will have 697 over 16, B is equal to 4. So, therefore, B natin is 64 over 697. We can now solve for A. You can use the first equation. So, 21A plus 16B is equal to 4. We substitute. We have 21A is equal to 4 minus 16 times 64 over 697. Divide natin yung whole equation by 21. We will have A is equal to 84 over 697. So, we substitute. We will have QP natin is equal to 84 over 697 cosine 10T plus 64 over 697 sine 10T. Next, we factor out pala yung 1 over 697 para lang mag-simplify. So, from then on, yun lang naman ang medyo mahirap dito yung pagsisimplify. Now, we substitute na ngayon dun sa value ng Q nat sa ating, to get the general solution, that is Q is equal to QC plus QP. Di ba? Nakuha natin yung QC, nakuha natin yung QP. We substitute. We'll have Q is equal to e raised to negative 20t times C1 cosine 15t plus C2 sine 15t plus 1 over 697 times 84 cosine 10t plus 64 sine 10t. This is our general solution. Now, we need to use the initial condition to find C1 and C2. So, take note, GS pa lang to. So, we still need to find the particular solution by substituting the initial conditions. Now, ang initial conditions natin, given naman dun, sinabi din naman dun sa problem, that is at the start of the system, yung initial charge mo daw ay 0 and your initial current ay 0. First use natin na at t is equal to 0, q is equal to 0. First initial condition. So, substituting, we'll have 0 is equal to e raised to negative 20 times 0. This is already equal to 1. Tapos, times C1 cosine 15 times 0. This is equal to 1. Plus C2 sine 15 0 times 0. This is equal to 0. Plus 1 over 697 times 84 cosine 10 times 0. This is equal to 1. Plus 64 sine 10 times 0. This is equal to 0. So, we will arrive, class, at C1 is equal to negative 84 over 697. Next, we need to get C2. Now, another initial condition is that the initial current is 0. But we don't have a direct equation of the current, so we need to take the first derivative of Q because we know that the first derivative of Q is the current. So, substituting, or I mean taking the first derivative, we have puro product to. So, we have Q prime is equal to product. So, C1 times e raised to negative 20t minus 15 sine 15t plus C1 times negative 20 e raised to negative 20t times cosine 15t plus C2 times e raised to negative 20t times 15 cosine 15t plus C2 times negative 20e raised to negative 20t times sine 15t plus 1 over 697 times, ito hindi siya product, so minus 840 sine 10t plus 640 cosine 10t lang. We substitute na ngayon the initial condition. Wag na natin munang i-simplify kasi again, it's easier to simplify kapag na-substitute na initial condition. And that is, your current is 0 when t is equal to 0. So substituting, we'll have 0 is equal to C1 e raised to negative 20 times 0. This is equal to 1. Minus 15 sine 15, times negative 15 sine 15 raised times 0. This is 0. Plus C1 e raised to negative 20 e raised to negative 20 times 0. This is 1. Times cosine 15 times 0. This is equal to 1. Plus C2 e raised to negative 20 times 0. This is equal to 1. Times 15 cosine 15 times 0. This is equal to 1. Plus C2 times negative 20 e raised to negative 20 times 0. This is again equal to 1. Equal to 1. Times sine 15 times 0. This is equal to 0. Plus 1 over 697 times negative 80 sine 10 times 0. This is equal to 0. Plus 640 cosine 10 times 0. This is equal to 1. So we will now have 0 is equal to C1 times 1 times 0 plus C1 times negative 20 times 1 plus C2 times 1 times negative times 15 plus C2 times negative 20 times 0 plus 1 over 697 times 0 plus 640 times 1. So we will arrive at 0 is equal to negative 20 C1 plus 15 C2 plus 640 over 697. Now we already have the value of C1. So we substitute. So we will have 0 minus negative 20 times C1 natin. Palitan natin ng negative 84 over 697 plus 15C2 plus 640 over 697. We will arrive at C2 is equal to negative 464 over 2091. Now, pwede na natin i-substitute. So, the function natin will be, palitan natin yung C1 at C2, that is Q of t is equal to negative to e raised to negative 20 times 20t times 84 over 697 cosine 15t minus 494 over 2091 or 2091 sine 15t plus 1 over 697 times 84 cosine 10t plus 64 sine 10t. Now, kung napansin natin class, in this equation, ang Q of C natin is e raised to negative 20 times 84 over 697 cosine 15t minus 464 over 2091 sine 15t. Now, in this equation class, this is our QC and this is our QP naman. Kung mapapansin, itong QC natin or yung complementary function natin is multiplied to e raised to a negative exponent. So, ano yung tendency? As time passes, what will happen to this value? This class will be approaching 0. So, as time increases, your QC will approach 0. So, pag nag-approach siya ng 0, ano na lang yung matitira? Ang matitira na lang is yung QP. So, ibig sabihin nito, class, at the time at which fully matcha-charge na or fully ay ma-establish na natin yung ating circuit parameters, mawawala na to. Ang matitira na lang is yung QP. Kaya itong QP nating class is tinatawag natin as our steady state solution because this is what will be left kapag na stable na yung parameters ng circuit natin. So remember, di ba, pag nag-close yan, hindi naman agad-agad ma-charge yung capacitor, hindi naman agad-agad, kumbaga, ma-charge yung inductor, etc. etc. So now, kapag na-reach natin yung time na yun or yung moment na yun, that is yung time at which this will approximately be equal to 0. At kapag naging 0 na yan, ito na lang yung matitira. So kaya ang tawag natin dito is the steady state current. Ayan. So that is it, class, for our discussion for chapter 7, which is the application of higher order differential equations. So we now proceed with the exercises.